extraordinary career path. He worked as a senior vice president in a multi-billion-dollar corporation, as well as academically. He served as a dean in a business school. So Dr. Dariush Rafinejad is a consulting associate professor at the Management Science and Engineering Department at Stanford. And he also teaches at Presidio School of Management in San Francisco and Haas Business School at UC Berkeley. And he has over 25 years of experience as a senior executive in high-tech industries in Silicon Valley. And many of them are multi-billion-dollar companies. From academic side, Dr. Rafinejad was an adjunct professor at Haas Business School at UC Berkeley and Dean of Management at Menlo College in California. Dr. Rafinejad has a PhD and Master of Science at University of California, Berkeley, and has done postdoctoral research at Imperial College in London. So welcome to UC Santa Barbara and Bren School, and looking forward to your talk. Thank you.
Thank you so much. Thank you so much. It's so wonderful to be here at UC Santa Barbara, and Santa Barbara is great. This is, I guess, is a typical students always have to sit way back. I'm just talking. I'm not going to ask any questions, so you're totally safe if you like to come closer. But I'm so happy to be here. As Professor Su mentioned, I'm at Management Science and Engineering Department at Stanford University. This department is in the business of management, but is under School of Engineering at Stanford University. So we have like our students, many of them have engineering background, which I would imagine many of you have. So what I would like to talk to you about, actually introduce myself, we have a group at Stanford which is called Sustainability Research Group in our department, and put some of the names there. Faculty members, there are 3 faculty members that we are working on. We have 2 PhD candidates currently, and a number of master's students, but these are the active ones who are working in various sustainability projects in our department. What I'd like to talk this morning with you is to talk a little bit about motivation for our research group and why it was formed and what we hope to contribute. And then also talk about some of the examples of the work that we are doing, some of the case studies we've done, some research paper and research work, and a course that I teach on the subject matter, and also share with you some of the future directions that we think we like to move on and do. My own background, as you heard, is mostly in product innovation and commercialization of products, supply chain, manufacturing, technology and processes development. And for many, many years, I was in solar energy industry originally, and then in the semiconductor industry for over 20 years. And all these years, except for the solar energy part, the semiconductor industry, the word sustainability did not even exist, and we even didn't speak that language whatsoever. And it was a very big concern of mine. And when I went to Stanford, graduated myself from industry, went to Stanford University, that was the very first issue I brought up, that we have developed very good methodologies in product development strategy, innovation processes. We have wonderful methods of supply chain management. They're highly efficient. We have done a lot of good work in manufacturing processes, operational management, quality control. All these management processes that have been used in the industrial sector and industrial context have been developed fairly maturely, and they're really very good. However, from the sustainability viewpoint and glasses, if you like, they are fairly poor. And so that's sort of was the primary motivation of us. And of course, you know, sustainability really is getting to a point that is not an optional subject anymore, and is not a nice thing, although probably is, and is practiced or considered as kind of an optional nice things to do. But you've seen these kind of graphs before, carbon dioxide level, the resulting temperature effect, even in the best case best case scenario, we're talking about very large temperature rises and climate change. And what is happening in sustainability, which is very important and is particularly requires a radical change in its thinking, is that sustainability attributes has both spatial and temporal dimensions. And that is, which is significantly different from the current practices. The time dimension, for instance, are these kind of effects that is only the accumulation over time that we see, like glaciers going away or temperature rising. And also on the human health side as well. A lot of environmental exposure, long-term exposure to hazardous material, chemicals that are cumulative in body, of human body, they actually impact the genetic function. So therefore have generational impact as well. So we see both a very, very significant dimension in time. And the traditional model of business, of course, is that we always discount the future. Future is not very important. All economic models that we use, we are wonderful in using net present values. But also has a huge spatial dimension of sustainability, of course. Again, in a different way, although we have always considered this in our models of business, but consumption of meat, for instance, has gone up 75% in 20 years and is expected to go another 50%. But the other aspect is that is this interconnectedness and globalization, but also not only globalization, but also concentration of production and means of production in certain places. For instance, as an example, soy is grown in Brazil, is fed to livestock in Canada, shipped to slaughtered and processed in the US, and consumed in Japan. So all of a sudden, this consumption pattern in Japan is being dependent or impacting natural resource utilization in Brazil. And there's also virtual transfer of resources, nitrogen, water, as a result of this. So one of the issues about this kind of situation is that not only this future transfer happens, but also creates a dependencies that perhaps not a very resilient, meaning that the behavior of such system is perhaps not very stable and robust and could be very sensitive to perturbations in any of these elements of this long supply chain. And manufacturing of products, of course, is even worse. Every PC that you have in front of you or your laptop and iPhones, they have much even longer supply chain than this. And because they're monopolized, they're actually they're not very robust. So in fact, that's one of the areas of my interest, area of research, exactly look at this subject and see can we establish a sensitivity pattern. And we've seen this lack of stability, if you like, in economic system, in financial system. We've had just recent crashes. Even 10 years before that, we had the dot-com crash and so forth. So these systems are they really resilient. So sustainability, what is also happening is that it is actually rising in forefront of public policymakers, but also corporate management. To what degree and what action is resulting from it, of course, that's the issue to delve into and examine. But generally, going back to the last chart, generally people are sensing without articulating or calculating, if you like, there's a sense that systemic risk in business is also increasing, particularly larger companies. So shareholder response is, in a complex way, are these kind of things. For instance, this is a chart that shows the energy kilowatt-hour consumption per capita over 30-year time period. And the blue line is California, which is flat, meaning that per capita energy consumption in California has not grown, while the US has steadily grown. And so this is usually California is credited because of the regulatory environment in California. And I don't think any of us would think, at least we don't think in California, that we are living poorer than the rest of the US. So we have maybe the standard living is about the same. If you look at globally, and actually it's looks even more, there's more contrast. This is CO2 emission. So United States, we are about 3 times world. This is CO2 emission per capita. So in California, we're doing better. We're twice the world. But in Texas, we're talking about 4 times. And Texas actually is twice in as much CO2 emission per capita than California. So this kind of consumption pattern or consumer behavior is another very important issue in 2 ways. Consumer behavior impacts short-term decision-making in corporate companies for what products do I develop, what management strategies do I adopt, but also the one that we generally not pay very much attention to is that corporations actually shape consumer behavior. They create preferences. Because if you think about all of the new emerging markets, when there is no product, there's a need created. 5 years ago, none of us had iPhone. Today, can we live without one? I mean, so our behavior actually changed because of the innovation or because of the strategies of the companies. So this is a bidirectional effect, if you like. So businesses are responding to the sustainability imperative today along 4 dimensions. They generally look at, this is a chart of showing the four points in here or areas that they're focusing on. I'm showing the colors, low priority, medium priority, and high priority in terms of, although there may be concern about, but is that a high priority or low priority on the strategic or investment decision-making at the corporate level or not. So number 1 is marketing. And what marketing means is that customer preference that I was mentioning before, risk mitigation, perceived risk of competition behavior, and also change in consumer behavior, and branding and transparency. Branding, if there's an opportunity to take advantage of the branding, or even mostly on the risk management side of the negative effect, perhaps because of NGO pressure and the more and more demand of transparency. The second aspect is laws and regulations. And generally, laws and regulations are comparatively neutral, meaning that if they're enforced equally, then you would say my behavior with respect to other competition should not change. The problem is that, unfortunately, life is not that easy, and regulations are not very homogeneous, geographically in particular. US, EU, China, UN, and many, many other countries, they are very different. And even if they are the same regulations or similar regulations, their enforcement varies all over. So corporations, therefore, although they abide, but brings in an opportunistic decision-making strategy that impacts your supply chain strategy. The third one is operating cost, which is generally most directly related to current practices of efficiency improvement. And at the point of intersection of sustainability and efficiency, meaning that less resource utilization increases efficiency and reduces cost. If I use less energy, lose less water, whatever material that I'm using, reduces cost and therefore increases profitability. So operational efficiency and efficiency, even in the use environment. The only issue about the sustainable operating cost is the priority, because corporations not only look at the efficiency of cost reduction, which is good, but what is the cost, what is the opportunity cost? Because if I have to invest in improving my efficiency of my operation, means that I'm not investing in something else. So this is not necessarily a no-brainer, if you like. because you have to see how do I make a decision. Entrepreneurial opportunity are the opportunities that because of customer preference or technological innovations, there are certain types of products that companies invest in. Conservation products, organic food, local products, recycling technologies, environmental capital, tourism, many things that we hear or you see being developed because of the opportunities, if you like, the entrepreneurial opportunities that arise. Where do companies in general behave? You can say maybe they're there or could be there. But one of the things that's missing in all of these four dimensions is that they're all opportunistic. And they're reactive and opportunistic. Reactive in a sense of risk mitigation, opportunistic because entrepreneurial opportunity, rather than proactive response to the sustainability imperative. And that's a real challenge for individual firm to decide because of what causes you or what constitutes that kind of proactive decision-making action. What we have to do really, we have to change the traditional methods because our traditional methods, the metrics we use, the analytical tools that we use, the design tools that we use are leading us to where we are. So we really have to re-examine the traditional methods and re-examine institutions, structures, operational decision rules, the objective utility even by itself. Objective utility typically is perceived benefit of which equates some need satisfaction of the user. And could we re-examine that? And this is although this kind of paints a picture of, oh, we have so many issues and problems to solve, but on the other hand, particularly for you, it's a great opportunity to innovate everything. Because this is a totally wide space of innovation, actually. Innovating technology, innovating management, innovating public policy. And that's what excites me, actually, about this whole field, because it's a wide space. Having been in the semiconductor industry, you know how the industries go. If you plot a rate of change in industries as they mature, I was in semiconductor for 20 years, or more than 20 years, and of course, in the 1980s, it was very, very steep. And then as we got to 90s, it got a little bit shallower, and then 2000s become very flat. So it's kind of I hope nobody is here from semiconductor industry. It's kind of boring to it. That was somebody from semiconductor industry. Didn't want me to finish that sentence. I was going to say, it's a very boring place to be. There's nothing happening. The rate of change is very slow, right? Well, you want excitement? Welcome to the sustainability white space. And everything is new and everything is wonderful. So we can make a huge change and difference. So that's why the teaching and research in sustainability space are critical enablers. And I'm kind of justifying why I got into this, I guess. But maybe also motivate you to do more and more of it. So I'm going to share some of that with you then. Teaching and research for development of new technologies and management tools. Integrating, big challenge, of course, is integrating environmental externalities into product and process development. Operational strategies, decision optimization, risk assessment, and mitigation strategies. Stand on this side, I don't know. Valuation of the natural resources, sources and sinks, and to what degree should we monetize them or maybe bring up new dimensions of assessment decision making that we don't have to monetize everything. This is one of the fundamental block of our methods because everything has to be converted into money because that's how our equations work. We have only sole variable. So system thinking in terms of multiple domains, network of multiple actors, and multiple scales, including time, meaning that system integration, that we can do actually sensitivity analysis for the stability and robustness of the system, and also not necessarily discount the future. Life cycle assessment, that I know many of you work at Bren, but integration of LCA into traditional design tools. Our design engineers use many sophisticated CAD tools, but are these CAD tools actually are integrated with LCA as a tool of helping them to design from the beginning products that are sustainable? Many other features actually are built in there. If you want to build, you can do a structural analysis on CAD tools. You can do heat transfer calculations. You can do all kinds of functional. But why not sustainability? Why not selection of alternate chemicals? So this is another big opportunity of development of tools. System simulation modeling, optimization modeling of decision making and risk management, which is system level thinking integrated over time. So our focus, research focus at Stanford, is firm-centric in our group. I'm not talking about Stanford, of course. I'm talking about just our group. Our group is firm-centric. Many of the environmental research and work has been done at macroeconomic level and for public policy effect, and we are focusing on firm level. What should the strategy of you as a CEO of your company be vis-a-vis sustainability imperatives or sustainability opportunities? The reason this is very important, of course, because that's where the actions are, but on the other hand, it's a very difficult one because you can always superficially make a response that, well, I'm just one company. I'm going to put myself in a competitive disadvantage. And also my action is only one small company. Well, maybe Walmart cannot say that, being number 25th largest corporate country in the world, equivalent. But most of the companies actually can make the argument that, well, I'm very small. And besides, how do I allocate externality? Even if you cost externalities, how would you allocate that to me? So, but however, that's our focus, is firm-centric. We are focusing on products, strategy of developing products, investment strategies, design development, life cycle management of products, focusing on supply chain, manufacturing, and operations, structure as well as the strategy. So these are our focus areas. So what we have done as a result of that, essentially we do various things. We develop case studies. These are case studies are, as you know very well, case studies are kind of twofold. They're either decision-making cases, like you're faced with certain particular challenge in your company and you have to make a decision. So these are, of course, have all underlying theme of sustainability decision-making. But also there are some case studies which are best practices cases, which you can go around, the industry, whatever industry you like to pick, and find out who are doing best practices. They may not be as good as you like them, but they're the current best practice. So we develop both of those kind of case studies and also use them in our teaching in the course that particularly that I teach at Stanford and other places I do. So I'm going to show you some of those cases. For instance, an example is the case I developed with Prius development. This is a sustainable, that Toyota Corporation used as a vehicle to establish technological leadership and then also business leadership. It's a very interesting case because the chronology of the development, actually the whole thing started in 1993. And at the time that Prius thought about development of a, what they call G221, which is meaning a vehicle for the 21st century, it really was a strategy against every marketing course that you take. Says that look at the trend in the market, what the customer behaviors are and what preferences are. And at the time in 1990s, this early 1990s, everybody wanted a Hummer. And Toyota Corporation, not in Japan, but in the US, and the US, of course, is a big 35–40% of Toyota's market is in the US. So you do all these marketing graphs and everything else and say, well, you have to develop another bigger car. And, but they sort of say, well, who wants to develop Prius? And so their goal was 50% over Corolla, improvement in fuel efficiency. In 1995, they changed their target. So, well, it should be 100%, twice as good. And in addition to a lot of other emission reduction, which they wanted to reduce by 10 times, like VOCs and carbon monoxides and other things. And in 1995, the president came and said, well, by the way, to the team, the product development team said, well, I wanted to do it 1 year faster. So they had all the twice as hard as their goal and 1 year less time. But anyway, they made it. And they, of course, the reason they did that was because they wanted to introduce the product at Kyoto Summit. So that's where they did, and they got, of course, this product is extremely successful, but not at the time. And so the whole research work here was, why did you do that? And also examination of the methodology of development itself, the risk that they saw, technological risk as well as execution risk throughout the development process. And just again what I mentioned to put it in context, this is the time when it was introduced in the United States in 1999, 2000. Gasoline prices were 99 cents. Hummer was introduced at the same time. So General Motors actually listened to the customers. So we have this and that. And of course, not because of Prius, but you see the trend. Toyota in 1994, when they developing Prius, was 60% size of General Motors. And of course, stories have changed. So another case I want to mention to you is Cisco Corporation that one of my master's students did. And this is a case when Cisco makes routers and other products like that, right? And they're in the business-to-business market. So AT&Ts of the world, they buy the routers. And so what they were doing in 2005, they had a $8 million cost center of managing the return products. And they had some second-hand connection with the recycling or end of life of what happens to the products after. But they generally believe that they were all landfilled. There was no centralized process, and reuse at the time was about 5% of end of life products. So as a result, they were filling out 12 football fields in knee-deep of scrap material every year. So this is a very interesting example because this person actually who did this at Cisco, she comes to my class, actually talks, and she's the one who just did this by herself. She just said, why not we change that? Right? And please remember that Cisco is a multi-billion-dollar company. It's a very large corporation. So $8 million doesn't sound like a very large number. So the idea was that, well, we have a lot of products that we are throwing away, and her argument was that they have a lot of value. And so also she used, to ride on the wave of the green corporation commitment, because the company CEO said, we are committed to green. She says, well, let's test it out. And so they said, well, why not we apply these reuse, recycle, rethink methods and go from return product, instead of going to scrap, why not we consider using them? So they did a lot of market research within Cisco and outside Cisco and said, well, we can use them for spares, for secondary market, internal use, philanthropy, and perhaps a scrap sub. So as a result of this work, over a 3-year period, the operating expenses from 120% to 39%, and product reuse went from less than 5% to 44%. An $8 million cost center became $100 million profit center. Another case was a Walker case, where this is a Walker Sustainable Chemical Production. This is a chemical company, manufactures many chemicals, and also manufactures wafers that are used in semiconductor industry as substrate for semiconductor devices. So they're in Germany, and So what they did was their practices was practically all of these initiatives were internally focused and initiated, although they were complying with regulations, but they really exceeded a lot of regulations and EU regulations for REACH, and they were being developed at the time. And so Walker became an active participant actually in promoting REACH regulations. But they also took some industry-wide leadership and set up some internal regulations. They used closed-loop manufacturing, on-site landfill. It's a very interesting one. The landfill is on-site. All these hazardous chemicals are actually being, and they're next to a river. I'll show you some pictures of this. And they use as much as possible local suppliers and local resources. They live within the community. Make a comment about that. So this is how Walker Chemical looked in 1969. And this is how it looked when I was there in 2007. It's a very pretty place, and it's got a river here and very green, and air was clean. And when I asked the person who was taking me around was the vice president of operations for one of the plants. They have actually many plants. This is a very large area. And I asked him, and we went out to have lunch and, after the tour in the morning. And we went to a cafe or restaurant, and very nice. And they brought fish. And he proudly said, this fish is from the river. And I said, oh, gee, do I want to eat this fish? I mean, you're talking about the plant that makes PVC and every bad chemical you can imagine, you know. And so you sort of said, so I had to say that. I said, are you sure we want to eat the fish? He said, of course. He said, this is a very good fish. And so when I asked him, what drives you to do these kind of practices in your factory? And he said, I care about this river because my daughter eats the fish from this river. That connectivity to the local impact of your behavior creates a huge impact on what you do. When we do a long supply chain structure, when it's very, very far away from us, our interests, although exist, we don't want no young girl eat a contaminated fish, but it's an abstraction. Right, and my daughter right there, local. So that's a huge impact. And you see so many of these, that's why I underlined a lot of these local operation, local landfill, local suppliers, local factories. And this is within a community. Actually, this is a city. It's a very nice city nearby. It's not some far away, remote area of chemical production. So that which forces you, of course, to do, this is the essence of leadership, if you like. So I'm going to show you some of, taking the time here, research papers that we've done. One of the things, one paper written as Economic Models of Environmental Sustainability is a critique of various models, essentially. It's just a critique paper. Because many people, submit how we can reach a sustainable economic condition or world. For instance, one argument is that, well, value-based. Our market economy drives the behavior according to the scarcity model, and if environmental commodities become scarce, their value will go up. If externalities become very harmful, their cost will go up. So it's a self-adjusting system. And this is a seminal paper by Thomas Friedman in the 1970s. That statement. So there's a model of regulatory model that if we have firm enough and hard enough regulations from governments globally, locally, and nationally, then we would force innovation or create an environment for innovation in the sustainability space. And therefore, we would achieve sustainable behavior. Their entrepreneurship model, we're doing good while doing well. Because of the opportunities occur, then entrepreneurs would take advantage of it and move society or economic system to natural capitalism, the efficiency in consumption and investment in natural capital, and a distributed economy model that, well, perhaps if you look at, imagine, of course, we don't have very much of it. We have some local, if you like, Spatial manifestation of this distributed economic system with self-managed CPRs, where common pool resources are self-managed by communities in harmony with the natural resources, and they're linked globally, and IP sharing. So this is a critical paper, and in fact, what I do in one of my classes, I have the students actually debate this and see who likes who. Actually, I don't give a chance to decide who likes. As you know how professors do to you all the time, right? You don't have very much chance. So I tell them that you, by definition, you love number one and number two, and everybody debates. So it's just a debate. Transition to sustainability, and this is a chapter, actually became a book chapter, which is mostly a review of the best practices in the industry. At the time, iPad-based, of the impact, population, affluence, and technology. Offers a lot of guidelines for sustainability practices for corporations. And also introduces an idea, which I like also to leave with you, is the cost of sustainability. There's actually interesting, in this paper, discusses an interesting parallel exists between the quality movement and sustainability. None of you are old enough to remember quality movement in 1970s and 80s, because our industry got, seriously threatened by Japanese companies, both in semiconductor industry and auto industry in particular, because of quality, simply. And in fact, Intel Corporation, as you probably may have read, the very famous story, they were forced to get out of memory business because the cost of manufacturing a memory device at the time was less than selling price of Toshiba's memory price. And we couldn't believe how could that be possible. And it was purely because of quality practices, yield in production. And so we had actually very interesting transition in that time frame in the 1980s, particularly when our companies, when US companies, paid a lot of attention to quality issues, including the companies that I was working with, paid attention, and we actually reversed the situation. In the semiconductor area, for instance, once in the 70s, the aggregate of US companies had about 70% of the market, Japanese had 30. By beginning of 1980, there was about 50-50% crossover curves like that. And then the situation again reversed. Late 1980s, US took over Japanese from semiconductor manufacturing, global aggregate market share. So quality amazingly made a huge impact, and we did the same thing in car industry and everything else. And so the reason I'm telling you the story is because perhaps cost of sustainability is the same way. And we have to look at it. And by the way, cost at the time, in fact, this is kind of a very strange way, because quality actually doesn't cost. It's only benefit, but we called it cost of quality at the time, and it's kind of stuck. And same thing with sustainability. Can we envision a parallel model of sustainability and quality, and therefore learn from that experience at the time and see how it perhaps can be extrapolated to the current environment, even if sustainability is somewhat more complex. This also talks about sustainability maturity index of corporations, compliance, supportive, active, proactive, and leadership behavior, and examines that. This model of sustainability is another paper, Modeling Sustainability in Product Development. Is a system integrates the cost of externalities and renewable, non-renewable resources in product costing. Assumptions is that supplier cost of manufacturing and product cost of consumable rises with accumulated consumption of non-renewable resources. So this is firm-based. So meaning that although the market is not necessarily behaving, because the size of your company is small with respect to the total economy, but your cost of product increases proportionally to the accumulated rate of non-consumable consumption. And same thing with consumables when it's faster than the marginal replenishment rate. And environmental damage as a stock is a cumulative value of contribution of your emissions, if you like. is a framework model, and sort of looking at what possibilities may be. Non-compliance to regulatory environments results in loss of market share, so that considers the regulatory model, and voluntary compliance or exceeding the regulatory environment results in some gain, either a market share or, in general, market share, and potentially a price premium. So design for sustainability. The factors of design is also built in there because R&D takes time and depending on the complexity, how it behaves. When you decide you want to do new R&D in sustainability, you're not effective immediately, of course. So those are built in the model. So the model looks like, so I'm not going to quickly go through that because I'm running out of time. Show you the model essentially shows the typical product model of R&D manufacturing use end of life, and look at the size of the market, look at the various environmental sink, and then look at various market segments, which have different regulatory behavior, and integrates the resources. Are you following me? Or? Okay? All right, sure. I'm rushing a little bit too much stuff. Of course, we're happy to send you any copy of any of these papers and discuss with you. By the way, I just, Vijay told me to remind you, this is a good opportunity to remind you. I'm going to have some opportunities after lunch to meet with you if any of you want to. I don't know, she told me about the room. Thank you, boss, the room, okay. Thank you very much. I'm glad you were there. So please, you're most welcome. I would love to talk to you and learn about what you're doing and what your interests are, and if you have time. So this one is a risk management work. One of our PhD students have done is managing potentially hazardous substances. Not hazardous substances, but potentially hazardous substances. So the issue of should you replace, under what condition, how would you make a decision to replace potentially hazardous substance in your product? And from an NGO's point of view, how should they influence a firm to actually replace potentially hazardous substance? Potentially hazardous substance, the third part, which is, these last two are future research that we are getting embarked on, or at least talking about getting started, of having a portfolio model. So the motivation, of course, is that chemicals are, I mean, we talk about global warming and climate change, which is extremely important, but equally important are chemicals. And this is a chart of showing global population in orange and chemical production annually going like this to 2050. So the regulatory environment, of course, is that Europe, you know about RoHS and REACH, US TSCA and California Green Initiative. NGO situation, there's activism, pushing for transparency, and trying to influence user behavior, public policy. There are organizations, for instance, of NGOs such as SIN in Europe, substituted now that are even going beyond the REACH prioritization technique of certain substances that they want to bring attention to and push the industry to take corrective action. So you see many examples of this case, actually a lot. There's a baby bottle, for instance, are manufactured with BPA. There's a chemical that gives a rigidity to the plastic bottles. And so over time, even over the last 20 years, there has been in public releases and even media reports that maybe this chemical is hazardous to children. But even today, it's not banned. But the consumer behavior has changed somewhat over time. And DuPont, even before CFCs actually were regulated by UN Action, Montreal Protocol, there was a talk of, is it hazardous, should we ban CFCs or not? In fact, it's not totally banned. Even now, Apple Corporation faces the same kind of thing with BFR, which is flame retardant, that even iPhone and Apple devices had even 2 years ago, 2 or 3 years ago. So toy manufacturers, and they are not banned. In Europe they are, but not here. And toy manufacturers, 3M, there are many, many examples. And so the question is, should the firm remove these substances from their products? They're not illegal, but you know that there's a potential that they're actually harmful. Should you remove it? If so, what should be the timing and intensity of the investment to replace? And should NGOs direct their effort toward the regulation, or should they maintain a pragmatic or antagonistic posture toward corporations? So those are the questions that the research was supposed to answer. And so the problem definition was a company sells a product that could be potentially hazardous. Regulations are not in place, but they may occur. And so the question, it was modeled as a dynamic programming model in 2 stages. When the stage 1 is development phase, meaning that when I develop a replacement model, and then the stage 2 is implementation, when and if, again, to implement. So both of them are if and when of the 2 stages. So the model looks like a demonstrate how the consumer perception and regulatory uncertainty. So the whole impact of this study is uncertainty. So the factors that impacts it are time, market share of the company. It turns out that the market share of the company changes their behavior because their sensitivity to gain and loss is different than the small companies, and market sensitivity to behavior. Would the market change significantly or not if you change your behavior? So those are the factors. Investigate how NGOs can influence. So essentially the way this problem was modeled was a planning period, and every period is a decision period from the firm's point of view, and the potential regulation announcement at the end of this period with certain given probability. So the questions are in stage 1 and 2. Stage 1 is a replacement decision, design, development of a product. Here is a replacement stage. So even if you design it, you may not implement it, meaning you're not manufacturing and introducing to the marketplace. So that's what the distinctions are. And so investment probability of development success is built in there, as well as one-time implementing this decision and no uncertainty about success. So although the R&D has uncertainty, the stage 1, but stage 2 doesn't. There is also, on top of this, there's a potential event in the middle with certain probability distribution, which says that event could be anything that may shift the consumer behavior. So there were potential loss and profits in each of those, and potential penalties. If the event occurs, there's a potential penalty if you reach toward the end of the time. And the cost, of course. So the case is about cost minimization, if you like. And you look at the gain as a negative cost in this model. So the model overview is that in the timeline I showed you, the decision is implement or defer. So because it's a dynamic programming thing, it's a recursive equation, so you solve from backwards, right? You solve from this stage backwards. And so you decide this is the event decision making. So if event hasn't happened, do you defer implementation or not? If you implement, then you have certain costs. If you defer, then you ask yourself, is the event happening with certain probability? No, or yes with this probability. And then is regulation happening or not? Again, with a given probability. So you go, this is a decision-making transition, if you like, from one state to the other. So in the decision-making, the stage 1 is the same way. It's a development stage, so there's a risk in whether the design works or not. So you decide, when do I start the design of replacement, or so that you have that question. And also, how much investment do I make? Meaning that what would be the rate of development of the product because of the investment that you make in this decision making. So it has the same kind of transition states. Won't go through that for you very much. So the results said essentially that we looked at various cases, and let me give you some managerial insight. It says large firms must dedicate resources to monitor and potentially. So it shows, actually the result here shows very consistent with the behavior of the company. The larger companies become, they do not essentially implement or embark on as late as possible. However, the smaller companies are more proactive and participate to early replacement because of potential market gain against the big players. So in fact, this case was actually tested, these kind of observations against some of the cases that I showed you before, real cases that happened. And as long as the threat of regulation exists, firms should actively invest in developing a replacement. So this is another insight. So what we are trying, the extension I mentioned before, so this is future research right now. What if you have many substances and we have many products? Some of the companies are very large. So what if you're Dow Chemical or DuPont, or you have multiple products, you have a large portfolio of chemicals? How would you decide which one you want to work on with a given limited resources of investment? So then you would have, of course, look at the various factors, such as Van Rojas list, highly chemical, or this is on the listed like maybe sin list, or maybe Walmart tells you to take it out, or California Green Chemistry says that. So there are all kind of various criteria, if you like, you set in here, and your substances for part numbers, so and so, and to make a decision. So this is an interesting research work that we're looking at. Another study for another PhD student, he did is look at the global supply chain model. What he did in this case was that create a global supply chain model that you are a firm, you want to decide how much of your product, what quantity of your product do you manufacture locally, and to what extent do you manufacture remotely. Just an example, for instance, would you manufacture in California or in China? And how would you decide that? And the factors that we are built in there is, am I totally out of time? No, okay.
Just to allow some time for...
Okay, sure, certainly. Okay, so this question, let me then jump into that. So we have these two firms. The government, both of the governments want to incentivize you to manufacture locally because of employment. However, the local environment has stringent environmental regulations, so they penalize you if you emit pollution, but also force you to invest in mitigation capital, like scrubber for your factory of some contaminant. And the remote factory, government incentivizes the industry to increase capacity for production, and has no regulation for environmental regulations. However, because of increasing stock of pollution, there's an health impact to society, and productivity of the labor reduces. So that's where the correcting factor of the balancing act in this system comes in. So the way the system was modeled was a system dynamics model, because it was integrated over time. This is where that now you have to look at the growth of the stock of environmental damage and relationship of that to efficiency or productivity of labor or health of the labor. So this shows a very schematic view of the model structure. If you know system dynamics, you probably have seen these kind of pictures that shows these kind of causal loops of various effects and how they relate to each other. Obviously, I don't mean to show you what it is. So we did a lot of various scenario analysis, looking at the clean tech requirements, low, medium, high level of investment, pollution tax level, as well as a hybrid policy, and shows how the system would behave. And just, I want to also mention to you that this course that I mentioned to you that we offer in the fall at Stanford, this is a course to Management Science Department. It's called exactly this title is the title, Product sustainable product development and manufacturing. Many of the cases I told you we do study in the case. And the students have a project to develop a sustainable product in the quarter. And also, or have a choice to go work with a local company and critically assess their sustainability practices. So with that, let me stop.
Thank you very much for your presentation. Apparently, Professor Rafinejad had a lot of things to share with us. We really appreciate that, and we probably have some time for a couple of questions.
My name is Sheetal, and I actually did work in semiconductor industry for a number of years. My question to you is regarding the sustainability evaluation, where there is a lot of uncertainty. For example, you have a new idea, or if there is an emerging technology, and you want to evaluate it for sustainability, meaning environmental sustainability. Economically, it has to be sustainable, and also in the social, in the people, it has to be sustainable. So when there are so many uncertainties up front, I know what's the literature is there about how would you incorporate uncertainties in the decision making, but I want to know what you think about how we should incorporate those uncertainties when we evaluate an emerging idea or emerging technology into sustainability decision making or evaluation.
Yeah, this is an excellent point, but my response to this question is that uncertainties in relation to sustainability is not different than any other uncertainties. In corporations, in fact, the CEOs who get very highly paid are the ones who are very good to make decisions, and you managers, as managers, you always have to make decisions with uncertainty. There's no probability of situation that you're going to be in there where you have all the information and there's a zero risk of risk-taking, and uncertainty is non-existent. Right? Those situations don't exist. You always face, irrespective of sustainability, totally irrespective, you always are faced as a manager with situations that you have to make a decision with uncertainty. And what does that mean? It means that you have risk-taking posture. You have to take risk. You have to have a methodology to prioritize among expected consequences of your outcome. And of course, you use always a objective function to optimize or minimize or maximize whatever this scenario may be. So this uncertainty issue is not unique to sustainability. Is the question. The question is that obviously within the time constraints that you have for decision making, which is you always have the time constraints, you do your best to collect information, and at the end also becomes your value system in prioritization. For instance, you could see, let me leave sustainability out for a second. You have a totally decision-making situation where your decisions are increase the short-term profitability of your product or long-term market share. So you have to make a decision. So sustainability is not really that much different. Because we haven't practiced it very much, it always presented or perceived as a new phenomenon or no conditions from the uncertainty point of view. But at the end, the issue, of course, becomes, well, what are the objective functions and what parameters do you use? That's a different issue. But the uncertainty, I don't think is a different, is a new phenomenon.
Please join me to thank Professor Rafinejad again.
Thank you.